We just keep looking for things that change in the world, and one of them was we kept wanting to, why can't we get information back? So the air handlers that we build, we could get information back from the fans. We can tell bearing temperatures and electronics temperatures and how they're operating and the speeds and all those things, and we wanted that in a fan filter module. And we couldn't get that, and everybody that we talked to said there'd be no marketplace for it, so we said, well, okay, so we'll put our money where our mouth is and we'll build something. So when we looked at it, we looked at what are the things that we wanted. We wanted a low net profile. We wanted something that could go into a small space. So we figured out a unit that's 15 inches tall, and with the way the airflow enters in here, we can be within an 18 inches of the ceiling. So there are shorter HEPA filters in the world, but ours actually, they always want more air, more room above them to get the airflow to come into the top of them. So we wanted to be able to adjust them from a smartphone, because that's the way the world's going. We wanted them to be Internet 4.0 ready, so we want to be able to take that data from the fan and use it for good, so that we know if there's going to be a failure at some point. And these things, they do operate forever. We usually go 7 to 10 years without any failures. But if you're in a critical environment and you know it, so if you put it above an aseptic filling line or something like that, you want to maintain. So we can set your set point by airflow. We can then get feedback that we're getting that airflow, and you get an instant alarm if something's gone wrong. So it's Modbus controllable. We can do it wirelessly or with a Cat5 cables and a control system. And Modbus is a universal, so anybody's control system, whether it be Johnson or Honeywell or Siemens, whoever, can do the programming and take that information back into their system. The other issue we were always having was everybody rates their filters at open free air. So you want 720 CFM, you want that 90 feet per minute, and as soon as you put some return ductwork on it, as soon as you put any kind of a static pressure on the room side, you can't get what you wanted out of it. And especially in the aseptic fill, if you're trying to get 90 feet per minute and you've got the T-bar grid and you've got things like that, you actually have to go to about 100 feet per minute out of the filter to be able to give you an average of 90. So we got a motor here that's so big that we can go 2.5 inches of external static. We could still do 110 feet per minute, and we're still only using 40% of the motor. So that drives two things. It drives the fact that we've got all that horsepower to give you the airflow you want, but it also drives down the energy cost. Because if you can take a big motor and run it slower, it's exponentially, every time you halve something, you get 3/4 of the energy reduction. So we're very energy efficient, which means you don't have a lot of heat going in, so we're not also adding a lot of heat into the space. So, I guess that was my next point. We can daisy chain them together. You hook up one of them, you can hook 12 of them together onto one circuit, so you need one electrical circuit, and you tie the rest of them together. 99.995 or better filters, so you tell us what you want for filters. We can have them as a one piece, we can have them as a room side replaceable, we could have them as a reverse flow. So if you want the HEPA face in the room and then exhausting out. The other nice thing about running a fan really slowly is it's not noisy. So if you've been in a room with a whole bunch of fan filter modules or even air handling systems, they're always noisy. They're putting silencers on them. I mean, we're selling this into hospitals now. We're from Ontario, Canada, and they've come up with is the requirement that you have less than 48 decibels of sound inside a patient recovery room, and they've mandated that they wanted HEPA filtered air into those recovery rooms. Well, one of our friends at Sunnybrook couldn't find a solution, remembered us, called us up. They had tested 14 different manufacturers. We were the only one that met the criteria. It does get louder. I mean, you get it up, but if you come over to booth 111, you can hear how loud it is, and it's pretty quiet compared to the rest of the industry. So again, the daisy chain wiring, you plug the first one into the wall. You can, power wiring and control wiring. Daisy chain, just a standard Cat5 cable from any electronics store. If we lose connection to the control system, we can program in an emergency set point. We usually program it in just a little higher than what you're doing anyway, but you'll never see a failure from the fan. The fan will continue operating as long as you've got 208 volt power going to the fan. So then, somewhere between marketing and what I came to talk about, I was told to talk about the HEPA filter, and I came here and found out that we're talking about smart critical display. Okay, so that's something else we do. So most people have temperature, humidity, in the room. Do the people in the room know it? Maybe yes, maybe no. You've got door alerts on your door. So is there another door in the hallway open? You don't want somebody else to open a door. You can either do that from an SOP, a procedure that you don't want somebody to do that, or you can put mag locks in. And of course, once you put mag locks in, then you've got all sorts of certifications, verifications, and all those things. And then you get your differential pressure between the rooms. So we've come up with a single display in the room, and it's all configurable. So you can say you can't go in because the door is open. You could tell it, put in here what the room number, what product you're running. Anything's programmable off your any kind of an operating system. Is my temperature right? Is my humidity correct? Is my air pressure correct? That could be the room side of it, and on the outside of it could be my differential pressure. Can I go through the doors? And then just what's the room? Is it in cleaning? Is it running a product? All of that information can be in that one place. If you come over to booth 111, you're going to see that we also have taken that information and we tie it to a white, yellow, red light fixture in the ceiling. So not only is that annoying buzzing noise over in the corner, but you now actually, if you're getting close to being out of spec, the lights, some of the lights, all of the lights in the room will go yellow, or as you get out of spec, they're going to go red. So now it's, I got to do something, I got to stop right now. So there's no, oh, I didn't know until afterwards, and then trying to convince validation that. So the other things we do, just as a quick summary, is the complete environment. So the wall systems, the ceiling systems are part of our package. And then where we started, I'm a refrigeration mechanic that started the company 36 years ago. We come from the temperature humidity control side. So we custom manufacture. Nothing that we have is a catalog, so we can custom manufacture any solution to any size and any configuration you want. That's me. Any questions? Anything I can answer? Anything I can confuse you with? The video doesn't run as well here as it does at home. It's got this great, oh yeah. So, all right. So, and it's like we like to say in our life, it's really all we're trying to do is connect dots. I'm trying to figure out who the original Greek guy that was that laid and looked up in the sky and said, hey, that looks like a horse, and that one. But once he said it, everybody believes it, right? So we're over at booth 111 if you want to actually play with the fan, if you want to see it, if you want to ask any questions. All right. Thanks for taking time out of your day.